Okay, example 7. It wants us to solve sine of 2x equals 0, where x is equal to or between 0 up to 2 pi. Alright, so we're going to do this one a lot like example 6. We're going to find where sine of 2x is equal to 0 in general, and then we're going to become more specific using our table to help us, okay? So, we're looking for where sine is equal to 0. Well, when it's equal to 0, that means it's on a quadrant. It's a quadrantal angle, okay? So, sine is my y. So we know there are two places where y is equal to 0, and that is going to be on the x-axis. So we're going to use the one on the right, which is when 2x will equal 0. Remember, we don't use 2 pi because we don't want it to equal 2 pi. It's up to, but not including, okay? But we do want it to equal 0. So 0, and then our 2x is equal to pi. Now, so to make it generic, we're going to put plus. Sine has a period of 2 pi n, or 2 pi, so we're going to put plus 2 pi n. And then we're going to solve for x. We're going to divide everything here by 2. And so we get x is equal to 0 plus pi n. And we're going to divide everything here by 2, which means x is equal to pi over 2 plus pi n. Alright, so let's make our table. And so we have our n. We have 0 plus pi n. And we got pi over 2 plus pi n. And we're going to start when n is negative 1. So 0 plus pi times negative 1. It's just going to give me negative pi. Alright, and so negative pi is too small. So plug in negative 1 to the other equation. So it gives us pi over 2 minus pi, which is a negative pi over 2. Again, that's negative. It's not going to be between 0 and 2 pi, so it is too small. And remember, we wanted to see that, okay? We wanted to see where it was too small. Then let's plug in 0. So we got 0 plus pi times 0, which is a 0 plus 0, which is 0. That's in between or equal to 0 up to, but not including 2 pi. So plug in 0 over here, so pi over 2 plus pi times 0. Well, pi times 0 is going to cancel, which just leaves us with pi over 2. That's between 0 and 2 pi. So now let's do when n is 1. So we have 0 plus pi times 1, which gives us pi. That is also between 0 and 2 pi. And then we have pi over 2 plus pi times 1, which is pi over 2 plus pi, which is 3 pi over 2. That is also between 0 and 2 pi. And then let's check when n is 2. So we have 0 plus pi times 2, which is 2 pi. Now remember, it's at up to but not including the 2 pi, okay? So that's too big. And so if that one's too big, then this one should be too big as well, but we have to check it. So we guess that pi over 2 plus 2 pi, which if nothing else, that's 2.5 pi, right? So that's too big as well. That's bigger than 2 pi. And so there are our 4 solutions. So we know, for example 7, that x is going to equal 0, pi over 2, pi, and 3 pi over 2. Okay? Now remember, on these, you keep going until you end up with an answer that's too big in each column, okay? So if my first column would have worked here, let's just say 2 pi would have worked, but the second column didn't work, that 2.5 pi, I still have to keep going in that first column there, okay? To see each column, you have to go until it's too big. It's not until one of them's too big and then you're done, okay? So make sure you check both columns for all of the n values. All right, so there's our solutions.